All right, so monatomic ions form from one atom. Polyatomic ions, if you remember that from math or geometry, polygons have many sides. All right, so polyatomic ions are going to form from many atoms. So by the end of this, you should be able to explain what types of atoms form polyatomic ions, how to tell them apart from monatomic ions, and so forth. So here are some examples. We've got monatomic ions up top, and then polyatomic ions down at the bottom. All right, so how to fill in this table, you can see, say, nitride forms a -3 ion. All right, it has one nitrogen circle, so it's got one nitrogen. So its chemical formula would be N with a 3-. All right. See if you can do nitrate. So nitrate is here. We've got the -1 charge is already filled in for us, but we have one nitrogen in the center and 3 oxygens. So our formula for this is going to be NO3-. All right, we'll do one more. Sulfate is right next door to nitrate. Has a -2 charge. What would that formula look like? All right, see if you can do the last two. I'm just going to pause it, and then they'll show up. All right, so there's those last two. So polyatomic ions all have multiple types of atoms in their ion. All right, so their formulas are going to have more than one capital letter. That's going to be, your way to tell them apart from your monatomic ions, which are only going to have a single capital letter. They might have a second letter, but it's going to be lowercase. So, think about this. How do these words tell you what type of ion you're dealing with? All right, so mono, 1. So monoatomic ions have one kind of atom in the ion. Whereas polyatomic, poly means many, so there's 2+ kinds of atom in the ion. All right, if you need to, rewind so that you can answer this question. But what types of elements were in those polyatomic ions? All right, if you remember, there was nitrate, which was nitrogen and oxygen, sulfate, which was sulfur and oxygen, ammonia was nitrogen and hydrogen. Those are all nonmetals. All right, here is a good summary of the key differences between your monatomic ions and your polyatomic ions. All right, there's the monatomic is made of one atom, poly is made from more than one. You do need to know those group 1A to 7A patterns, which are important for the monatomic ones. There's no kind of general rule like that for the polyatomic ones, other than they will be made from nonmetals. B group monatomic ions can form more than one kind of ion. The metals form positive ions, and then some other observations just to kind of keep track of. Polyatomic ions are always made from nonmetals. Most of the time they have a negative charge. There was a common one you'll see that doesn't follow that rule is ammonium. The atoms that connect together to form the polyatomic ion generally have similar electronegativities, which is why they're all nonmetals. Nonmetals are all kind of in the same area on the periodic table and have those high electronegativities. Within the polyatomic ion. All right, so we've got our NH4. We will define covalent bonds in a moment, or in a future lesson, but the bonds within the ion are covalently bonded, and then this group has a positive charge that can form an ionic bond with something with a negative charge. Little caveat there. So, see if you can identify the monatomic ions versus the polyatomic ions. All right, give this a shot. If you are doing this correctly, these guys that don't have charges at all can't be classified as anything. All right, and then your monoatomic ions, the ones with circles, just have a single atom in there. This is aluminum. Then we got nitrogen. All right, so if there's two letters, the second letter is lowercase. There's another non-ion. All right, and then the boxed ones are going to have multiple capital letters. So I won't throw this in here because this is going to show up on your quiz question, and honestly, the way it is written, this is actually a really poor question. But it says, which element will likely form which element combination will likely form monatomic ions? So I think what they are saying is that they would form opposite ions, or they couldn't possibly go into a polyatomic ion, and they would actually form monatomic ions. So for me, the trick to this was argon and krypton are noble gases. They're not going to form monatomic ions at all. All right. The rest of this, carbon generally doesn't form an ion at all, so you can kind of cancel that one out. But you can definitely cancel that out if you add could not be a polyatomic ion, because here we've got two nonmetals, here we've got two nonmetals. So those guys can make polyatomic ions. The only thing that couldn't be polyatomic would be the potassium and the iodine, because potassium's a metal. So this is the right answer to the quiz. One other quick thing, this is a little different than what's on your quiz, but I wanted to cover the term oxyanion. So oxy should make you think of a type of element, oxygen. So oxyanions have oxygens in them. So, and they will be negatively charged because they're anions. So which of the following would be an example of an oxyanion? The only one with oxygen. All right, or if it has oxygen in it, it's an oxyanion. If it doesn't have oxygen in it, it's not. Hint, hint.